This is not the first time the term lab leak has entered the public lexicon. The term describes an unintentional release of pathogens, such as viruses or bacteria, from research facilities into the outside world. Lab leaks can occur due to human error, equipment failures, breaches in safety protocols, or mishandled transport. History does remind us of the potential consequences. In 1979, a Soviet military lab in Sverdlovsk became the site of one of the deadliest accidents of its kind. Faulty filtration systems released anthrax spores into the surrounding area. At least 66 people died, though estimates suggest the number could be far higher. Survivors described a surreal scene. Hospitals overwhelmed, soldiers scrubbing streets, and a city shrouded in fear and secrecy. Decades later, in 2003, laboratories in Beijing and Singapore accidentally released SARS, sparking renewed scrutiny of global biosafety practices. And then, in 2007, the United Kingdom experienced a containment failure that unleashed foot and mouth disease, decimating livestock and costing millions. What connects these incidents is the simple truth. Even in the most secure facilities, humans are fallible. And sometimes these systems are quite imperfect. Biosafety labs ranked by levels of 1 to 4 represent increasing degrees of containment, with level 4 being the highest. These spaces are like something out of a science fiction movie. They've got airlocks and full body pressure suits and air filtration systems designed to trap the smallest of particles. But when protocols are ignored or equipment fails, the results are actually quite catastrophic. When we're thinking about lab leaks, you have to ask yourself, how do they even happen? One of the first thoughts is human error, because a single misstep like improperly sealing a sample, it could have devastating effects. Then there's safety protocol breaches, even minor lapses, such as failing to wear proper protective gear. It can compromise containment. There's also equipment failure. Malfunctioning HEPA filters or storage systems, they can release pathogens directly into the environment. And then there's also transport mishaps. Pathogens can escape during transit between labs or improper disposal. The COVID-19 pandemic revived these fears on a global scale. For years, debate has raged over its origins. Was it zoonotic spillover, as with previous coronaviruses? Or did the virus escape from the Wuhan Institute of Virology, where researchers studied similar pathogens? While conclusive evidence remains elusive, in January of 2025, the CIA recent assessments do bolster the lab leak hypothesis, joining earlier findings from the Department of Energy and the FBI. And what makes this debate more than just an academic exercise are the human stories behind it. Imagine the researcher who unknowingly carried a virus home to their family, or the whistleblower silenced for questioning protocols. Picture the millions of lives forever altered by the pandemic. Grieving families, overwhelmed hospitals, and frontline workers pushed to their limits. The stakes here are not merely scientific, they're deeply human. Preventing future lab leaks requires global cooperation, though, transparency, and unwavering commitment to safety. Laboratories must rigorously train staff and enforce strict biosafety protocols, maintain state-of-the-art containment systems from HEPA filters to secure storage, and conduct regular inspections to identify vulnerabilities, while establishing clear and enforceable transport and disposal protocols. The COVID-19 pandemic is a sobering reminder that small failures can potentially lead to unimaginable consequences. And as the world grapples with the origins of this crisis, one thing is clear. The path forward demands vigilance, integrity, and collaboration. So in the end, whether through zoonotic spillover or a lab leak, the story of SARS-CoV-2 COVID too will serve as a lesson for generations to come. And in regards to lab leaks, the question is, will we learn from this? These are Interesting Things with JC.